everybody uses electricity. I mean, actually, probably 3/4 of the world has electricity, and it's something that's an integral part of urban life. It's sort of necessary to the way we live, for better or for worse. There's a lot of interest right now in introducing renewables into the electricity grid. And wind power in particular has at least potential to be a cost-affordable alternative to fossil fuel sources. One of the tricky parts with wind, unlike the fossil fuel or hydro resource where you can turn it on and off whenever you want it, the wind kind of blows when it wants to. What we're studying here is trying to figure out, as the wind goes up and down and as it fluctuates, how do we integrate that new energy resource into the existing electric power grid? What is the cost of integrating that fluctuating resource into the power grid? One of the sort of most basic things that's kind of unique to electricity is that we have to produce electricity and consume electricity at exactly the same rate at every moment. And so when I flip on a light switch, some power plant has to generate a little more electricity to meet my additional demand. The grid in the United States is just a word that we use to refer to the entire electricity infrastructure. It's an interconnection of transmission lines that are high voltage power lines connected with one another so that any electricity that you stick in at one point can be delivered to any point within that grid. It's a nice infrastructure in that you can generate electricity basically anywhere and deliver it to any other location. When we think about the grid really includes a lot of different components. There are thousands of power plants in the eastern United States. I mean, I think something on the order of 5,000. It includes a lot of human components as well. So there are human operators that sit behind desks and monitor the status of the power grid, trying to make sure that generators turn on and off at the right times. There are markets, so just like we have stock exchanges for stocks, there are power exchanges where people are constantly trading electricity financially. And so all these things are interconnected. Sometimes we think of them as agents. So you have human agents and generators that are sort of mechanical agents, and they're all working together to produce electric energy. And it's kind of miraculous that it works as well as it does, actually. In our research, we're trying to model all these pieces together instead of looking at each one separately, and seeing if these pieces together tell us things that we wouldn't see if we looked at any one piece very myopically.